Hey guys, what's up? This is RMA. Welcome to another RMA Fire tutorial. And today we're gonna be talking about sand in Houdini. So let's see how creative we can get with creating cool stuff using sand in Houdini. This is what we're gonna be creating today. So a few cool things that we can point out about this piece is that you can see the layers of color that I'm getting when we destroy the tiger from RMA Fire. All right, you can see the different layers of color, you can see the interaction, and you can see that this is not regular sand. This is clustered sand that looks super fun and let's say eye candy-ish. So let's jump into Houdini and check it out. Alright guys, so when you open up Houdini, my scene, you'll find the same thing that I've showed you on the other tutorials, which is this very simple like environment and light rig that I created, and a few cameras. If we pull out from the scene, you'll notice that we have a ground, we have this little light here and this light right here, both which I was playing around with, and you guys can totally move them around and see what kind of different results you get with an intensity of 5 and an intensity of 9, which with the HDRI that I'm providing for you guys, which is already set to $hip, textures, and right here, texture 19. All right, this is my favorite studio lighting texture. Okay, I'm just gonna turn them off so that they don't bother us. This is not a lighting tutorial. And of course, we have a few cameras in the scene as always. You will see 1, 2, and these are equivalent to the same cameras that I showed you guys at the beginning renders of the tutorial. Okay, so let's turn these two things off and let's look into how this is made. A grid. That's how we start. So as simple as a grid, a small grid. Remember, let's hide everything else. Scale matters here. If you make this really large or really small, it's really going to impact your end result. So a good rule of thumb is dropping down a box, because we know that a box is 1 meter by 1 meter, and seeing that this is approximately a 2 by 2 meter simulation, which is very handleable for what I'm using on my technical specs. We want to use a UV project and project UVs, and then a UV quick shade with whatever texture you want to use. So remember, on a UV quick shade, you hit initialize here, so that once you hit enter on the viewport, you can move this texture around and you can kind of like figure out however you want to use it. And what the catch is that when we apply it later on, I'll show you guys in a second what we need to do with these UVs. So let's set up our base. Let's drop down an extrude and make sure that our output back is selected with a little bit of extrusion, right? This is what we're gonna turn into sand. Now drop down a VDV, and VDV you can play with the voxel scale so that it's a little bit tighter, and then a VDV convert node here, and converting these to polygons so that we can nicely like smooth out the edges of the geometry, and we have this base piece to start playing with. Okay, let's remove this vellum grains that I had right here because it's just a test. Now here's where you add your vellum grains. Now what are grains? Grains are just points. Don't be fooled by the fact that they create like little spheres here. That's literally just for visualization. When you create a vellum grains, it's basically just creating an IS grain attribute, and it's creating a little bit of mass. If we middle mouse here, nothing, we don't have any attributes. Middle mouse here, IS grain, mass, P scale, and V. It creates a P scale as well. So once we drop down the vellum grains, you want to say create points from volume, and you want to say particle scale. Particle scale is what's going to dictate the amount of particles that we're going to have in there. So vellum grains, drop down a vellum configure grains, connect your geometry here, and you will notice that you want to create points from volume. It's immediately going to create the points, and then you want to say 0.05 for example, and it's going to give you the resolution of equivalent to 0.05. 0.01, that's going to give you a higher resolution, and you can turn off the display as spheres here, and it's going to give you this different result, like with more like not necessarily like spheres, like just points. If you turn these two things off, which is what it is, it's points, but it has a P scale. The reason being is because the P scale is going to determine that the points understand where they collide with each other. That's why the points are not gonna go on top of each other. That's why this is different from like a pop simulation, and it's so powerful. Okay, so we have our vellum grain set up. Then we're gonna do a group, and the group is basically just selecting the points on the inside. Here's how we're gonna isolate a different color for the inside. So on a group, if you drop down a group, you select it here. There's multiple different ways of creating groups, but I wanna do a bounding box. And a bounding box, if you make sure that this is set to points, this is what's gonna select the points that we're gonna put into the group. So we have an inside group, and then we have a delete, which is deleting the inside group, the sandwich, the stuff outside, and this is deleting the stuff inside. See? So we know that this right here is our inside points, and our inside points, I'm doing a color and I'm doing a bounding box from that color to give it this nice variation. So like these are the colors that we're gonna have on the inside particles once we simulate this. Okay, then I'm doing a group again, and I'm saying this is my inside points. Then for my outside, this is the sandwich part. This is where I want to have my UVs. I'm doing the UVs from outside here. I'm connecting it here. Let me show you guys how I did that. On my UV project, I'm selecting, I'm creating action, and I'm creating create reference copy. So if we create a reference copy, anything that I change here, if I wanted to change the way that this looks, it's immediately going to change it here as well. But here's the only catch. Right here, this is set to vertices. Vertices is used to display UVs on geometry. We want to do it on point level. So if we select here and we right click here and we say like delete and we change this to points, now the UVs are being set to the points. And if you drop an attribute from map and you copy the texture here into this input, then you are going to get the same result but on a point level. And this is great because it's storing this color onto the points. And then we're gonna save this on an output group. Now once we merge them both together, we have our sandwich, we have the colors, and we have the information that we need to start setting up our simulation. That is key. That is how you can create like different color for points on any kind of simulation. Point simulation or grain simulation, okay? Now, what I'm doing here is saying stopped is equal to 1. And then I'm saying out geometry and out constraints. Then you want to drop a dot network, okay? And we're going to create our Vellum grain simulation inside of a dot network. So come here, and this is what we're going to set up. Basically, the way that this is done is you drop down a dot network, and inside of our dot network, we're gonna construct this little network that, don't be afraid of it, is actually very simple. We're gonna delete this to make it even simpler. And the only things that we're really gonna be worried about is the one on top for starters. Okay, so drop down a Vellum object. This is gonna say, this is Vellum. This is telling Dobbs, okay, we're working with Vellum, and we're gonna drop down a Vellum subsolver inside here. The subsolver is what's going to activate the stopped and the velocity. So we're transferring this every frame so that Vellum knows, okay, activate these particles, these ones can move. And that way, when we hit Vellum simulation, the whole thing of the points is not just gonna fall down. It's only going to fall down once they begin to get infected by this collider, okay? Hold on, I'll show you the trick. So we have an object merge, an attribute wrangle here, which is saying stopped is equal to 0. So we know that the beginning of the simulation has equal to 1 the stopped. So they're all stopped. Once they get infected with this, they activate, and that's when they move. That's the trick here. And then we're attribute transferring those two attributes, the velocity and the stopped, so that, and you want to make sure that your flag is set down here. This one right here, I'm not even using anymore. You want to set your flag to down here so that Houdini knows. And I'll show you guys really what that is doing. So we'll come back to it. what we're gonna do here real quick is create this little brush or any kind of shape. This is where we are gonna do a few copied boxes, a few boxes that are being copied here, and then they're being merged, and then we have this like very simple kind of brush, right? And then I'm just centering it with moving centroid to axis, VDV, converting the VDV just so that it becomes a little bit smoother, and then adding a little bit of noise. Nothing fancy. This is only my brush, my collider. And then I have a few different transforms here that I'm animating. And then once we merge them, we're gonna have like all of these little things being animated like this. Then we have a transform so that I can kind of move them up and down to see like from our points, like how deep this goes into the points and how it kind of swooshes them around. All right. And then the trail computes the velocity. Now, what's happening inside the network is something that I'm gonna recreate outside here for you guys to understand. So if we have our tops right here, I'm gonna do an object merge, and I'm just gonna grab this here, just for the sake of showing you guys what's happening. So we have this. I'm just gonna delete the color for now so that I can show you guys and visualize this. And then I'm gonna do a color, and I'm gonna add the color here, and I'm gonna make this red, and our infection is gonna be infected onto something black. Okay, and then I'm gonna do an attribute transfer, which is basically what's happening on the inside. This is an attribute transfer, and I'm transferring this red onto the points here. But right now I only want my CD, and I want this to be very little. And then when I move them, you'll see that they're basically infecting it here with color. But inside, instead of color, we're saying, no, I don't want to see the color. Just infect it with the velocity and with the stopped. So it's overriding the stopped inside of our subs, okay? Inside of our sub solver. So if you come here and you increase this, you can see that the distance of infection is very small. You can play with that, but if you increase it, it's going to infect more points. Then you're going to drop down a Vellum source, and then the source is your out geo. Okay, so we select here, it's this one right here. And then the second source is your constraints. So if you hit here, boom, this is my constraints. It's basically the same thing. Okay, and then I did a sticky note here for two parameters to play with: repulsion weight and the repulsion. So if we select this, you will see that that's basically all that we need to input here so that the Vellum source knows what our source points are. Now, if we hit the Vellum solver, you will notice that I did change a few things in here. And what you want to do is on your Vellum solver, so you can play with your velocity damping. You will see that if I revert this to default, it's usually set to 0. But this is just gonna damp down your velocities. Your substeps is going to calculate the amount of information that the simulation is doing. I set it to 5, which is what's recommended with this kind of grain simulations. And then you can play with your static, threshold, and dynamic scale. So these are the main parameters that I moved. On the advanced, we can see that really what really matters is playing with your grain collisions. And I'm playing with the maximum neighbors, which is set to 45. If you play with the attraction weight, it is going to control how much these particles stick together. And that's what I'm using to like clumping them so that they feel kind of like sand that is sticking together. And then also the attraction is going to attract the particles that are nearby to like feel like more squishy and more water, more like wet. That's a good word for it. So I'm gonna reduce the resolution so that we can play with it for a sec. And come back in here. And I'm going to just select this. And I'm gonna hit play. And this is most likely not really gonna work that great because with sand and with this kind of stuff, you wanna kind of like have a good amount of particles to play with. And you can see that it is quite slow. Okay guys, so after that I'm adding gravity, and then finally I'm getting a ground plane so that the particles, once they fall, they have somewhere to fall on. And then this right here is our collider, which is basically what, if we click here, it is our collision source right here. So we want to make sure that we are at the very bottom. Oh, and the last thing on the collision source is that you want to set the bullet to concave. What the concave is going to do is it's going to give you much more accurate collisions. And if we display the geometry, we're going to be able to see them. And with the concave, you're going to get like tighter collisions. You can also do VDV, or there's a few different options that you can use to play with this parameter. Okay, so since these parameters are really small, I'm gonna do a few flipbooks, and you guys are gonna see the difference between like what each of them is actually doing and how the max neighbor scale, which is the maximum number of particles that are considered when searching for a potential collision, is calculated, how the attraction weight changes, and how the actual attraction changes when we do this kind of simulation. The other thing that I didn't touch is the repulsion and the repulsion amount. It is not touched either. It's basically just playing with these two parameters here, the attraction weight and the attraction. Okay guys, so we've done through all the trouble of playing with that. Let's have a look at what the final simulation is going to look like. If we scrub, you're gonna see that we get like this really cool stuff happening. Okay, so what I'm doing in the end is just an attribute randomize, setting it to p scale, and just playing here with this custom ramp value, so that my values go fit between a 0.6 and a 1.5 in the scale of the points. And finally, I'm splitting it between my outside points and my inside points. I mean, outside and inside. I said it backwards. And then what I'll do is on these two render nodes, I am going to input here the inside points and here the outside points. And this is what they kind of look like on a flipbook. Alright guys, and then the last thing that we want to do before we render this bad boy is making sure that on the redshift this is set to particles and that the particle scale is set to 0.07. And you don't want to ignore the particle scale because we already set it so that they're all different scales, but right here you can change the overall scale of the whole thing. Okay, alright guys, a lot of information. This is a deep tutorial. Leave your comments, tell me what you think, and subscribe, and I'll be back with more.